Find all of the unknown angles and sides of triangle STU. Give all measurements to 1 decimal place. Right, so we look at the triangle, no right angles. The first thing you can see, you've got these two sides. So you've got TU and you've got TS. So the 17 and the 13, and then you've got an included angle, a trapped angle. So when you've got two sides and a trapped angle, and you are being asked for the other side, that is angle side is cosine rule. So the formula sheet works in terms of C. It gives you the formula with C as the subject, or C squared as the subject. I've just from doing the GCSE for many years, I've just got it remembered as A squared equals B squared plus C squared minus 2BC cos A. So I'm going to stick with that. If you want to label it using the formula sheet way, that's fine. Just remember the side you want, or the angle you want, if you do it like that, will be C. But for the way I'm going to remember the formula, which is this, something like that. So I'm interested in A being what I want. Well, if it's a side, then the lowercase a is the side. If it's an angle that I'm being asked to find, then it's the uppercase A. Knowing that uppercase and lowercase are opposite each other. So I'm just going to label it like this. I'm going to call the T, the A, the thing I need to find. This is angle A, and B and C are just the other two. So then I'm just going to write down T squared equals 17 squared plus 13 squared minus 2 times 17 times 13 times cos 80. Okay, simple as that. Cos 80 is not very friendly. In fact, you certainly don't want to be doing this without a calculator. So make sure you are in degree mode. We are in degree mode, so we're going to do 17 squared plus 13 squared minus 2 times 17 times 13 times cos of 80. So that gives you an answer for T squared. So it's 381.2475. So that's T squared. So T is going to be the square root of that. So on your calculator, square root ANS. Square root ANS, and that gives us 19.52556. So we would say to 1 decimal place, T equals 19.5 centimeters. Okay, so I'm going to put that on the diagram. Just look at the question. We've been asked to find all of the unknown angles, all of the unknown sides. So this is now 19.5 cm. Now you have a choice. Once you've got 3 sides, you could then go on to use the cosine rule, but the sine rule is usually easier. So yeah, once you've got a lot of information like this, you really could use the sine rule or the cosine rule. But I'm going to start with, we'll just look at pairs of opposite sides and angles. So you've got the AT is opposite the side T that we've just found. You have 17 is opposite this angle. And we have 19.5. And we have 13 opposite the top angle. Now, we only need to find one of these because there's only 3 angles in the triangle, so it doesn't really matter. So I probably will maybe just find the top one, TUS. TUS. Okay, so for the sine rule, you're going to do sine A over A equals sine B over B, or basically sine of an angle over the side opposite equals sine of another angle over its side opposite. So I'm going to put sine TUS, or I probably could have called it U, but it's a bit late now. Sine TUS over the opposite side, which is a 13, equals, and so we're going to have to use the only other pair we have that does involve this 19.5. So equals 19.5 is the side, it's on the bottom, and it's sine of the angle opposite, which is 80. So sine of TUS must be 13 times sine 80 over 19.5. So sine TUS is going to equal 13 times sine 80 over 19.5. That gives you an answer of 0.6565. And so the angle TUS must be the inverse sine of that. So shift sine ANS equals, that gives me an answer of 41.03, so 41.0 degrees. Go up to our triangle, put it on. So TUS here, and it looks reasonable as far as the diagram goes, so 41.0 degrees. 0.0. So then if we want to work out the other angle, which could be TSU, so TSU is just going to be 180. Take away the 41.0 that we just found, and take away the other angle in the triangle, which I think was at 80. Take away the 80. So that's just going to be 100, take away the 41.0. So 100 take away 40, 60, take away 1 is 59.0 degrees. We can then go back to our diagram and put that on 59.0 degrees.